This module will discuss various structure types typically used and site conditions that may influence design. The most common usage of box culverts is to carry water under roadways, but they are frequently used as multi-use path, pedestrian, or wildlife underpasses as well. Box culverts may be either single or multi-cell structures. Hydraulic and other requirements at the site determine the required height and area of the box. Hydraulic design of box culverts is described in the Wistad Bridge Manual, Chapter 8. Once the required height and area of the box culvert is determined, the selection of a single or multi-cell box is determined entirely by economics and structural design. Barrel lengths are computed to the nearest 6 inches. For multi-cell culverts, the cell widths are kept equal. Concrete slab structures are adaptable to roadways with a high degree of horizontal curvature. This superstructure type is functional for short to medium span lengths, on the order of 20 to 60 feet, and is relatively economical to construct and maintain. The practical range of span lengths for concrete slab structures can be increased by using haunched slab structures. Pre-stressed concrete girder structures are a competitive structure type option due to their economical upfront cost and minimal long-term maintenance requirements. Future widening can be accomplished with relative ease. For more information about pre-stressed concrete girder bridges, refer to Bridge Manual, Chapter 19. Here's an example of a multi-span pre-stressed girder bridge. Precast pre-stressed concrete slab or box structures have the advantage of rapid construction where traffic must be diverted. These structures are also able to be constructed without false work, which is a distinct advantage when vertical clearances are critical during the construction phase. Experience indicates that from an initial cost standpoint, these structures are more expensive to construct than concrete slab structures. For more information, refer to Bridge Manual, Chapter 19. The concrete rigid frame is more costly than other superstructure types. However, the concrete rigid frame is known for its aesthetic value and is used primarily in public parks and urban areas where the span lengths are similar to concrete slab structures and where approach embankments are relatively high. Steel beams are recommended due to depth of section considerations for short span structures and due to their economy in comparison with other materials or structure types for longer span structures. When pre-stressed girder design requirements are exceeded with long span lengths or high curvature prevents their use, steel beams are a good choice. Welded steel plate girders may be beneficial in areas where long span requirements or when tight vertical clearances are an issue. Steel plate girders have greater versatility in allowing variable web thickness and depth, as well as variable flange thickness. Future widening can be accomplished with relative ease. They are also less expensive than rolled steel sections with cover plates. Steel box girder structures have span length capabilities similar to plate girders and exceed plate girder ability to handle tight curves, typically seen in interchange ramp structures. Current experience reveals that steel box girders require more material than conventional steel plate girders. However, due to redundancy concerns, use of single box and two box girder bridges should be avoided unless absolutely necessary. Unusual bridge sites, such as major river and harbor crossings, may require the use of longer span lengths than conventional deck-type superstructures can accommodate. For such conditions, a steel-tied arch or steel truss can be effective. When fracture-critical or non-redundant structures are used, the structures require in-depth inspections every 24 months. These inspections are costly and time-consuming. Many fracture-critical inspections require the use of a snooper truck. Every element of the structure must be inspected within an arm's reach. The most commonly used pier type for grade separation structures is the multi-column pier. Hammerhead piers are used for all types of crossings, but commonly used for stream and railroad crossing structures. The choice between using a multi-column pier and a hammerhead pier is based on site considerations, economics, and aesthetics. For tall bridges and multi-level interchanges, a hammerhead pier is generally the most economical and attractive pier type available. The selection of the proposed structure type is based on evaluation of the structure survey report, including accompanying supplemental data, site considerations, anticipated construction costs, and past experience. In selecting the most economical structure, ease of fabrication and erection, general features of terrain, hydraulic considerations, constructability, roadway geometrics, subsurface exploration, and geographic location in the state of Wisconsin are considered. The proposed structure should blend into existing site conditions in a manner that does not detract from its surrounding environment. Every attempt should be made to select an aesthetically attractive structure consistent with the structural requirements, economy, and geographic surroundings, while considering the future maintenance needs. The use of non-redundant structures, including single-box and two-box steel-girded bridges, should be avoided unless absolutely necessary.